And here's the objectives. Objective A, define polygons.
My turn! B, differentiate the different kinds of polygons by their sides.
By the way, C, find the area of the polygons using given the...
A cool looking leaf! Let me take it to 𝓳𝓚. 𝓳𝓚, take a look! I found a cool looking leaf!
Oh, that's something.
This leaf is so cool! And it's not just something, it's cooler than you!
Should I be offended? Anyways, it's not a cool leaf. It's an example of a trapezoid.
Trappy what? I only know trap my ball!
Lesson 1, polygons.
Since you said earlier that a leaf was a polygon, what is a polygon?
What? It's polygon. Poly means many and gon means angle.
Oh! So it means, many angles?
Who knew you actually had a brain?
Shut up!
Hey B,
Hi, Jolly.
those two are so immature, always fighting and napping.
Yeah, but anyway, polygons are a two-dimensional object, and since its shapes is always a closed figure.
Wow B, you're so smart. Are you a professor just like 𝓳𝓚?
No, I just got hit by a rock.
It's actually smart, B. You actually use your brain now, but I'm the one teaching here. So, to start our lesson, let us look at this polygon. Can you figure out what this polygon is?
Oh, me!
Yes, Jolly?
It's a trapezoid, right?
No it isn't. It's a quadrilateral.
What?
Quadrilateral, B. Seriously, don't you guys even know one thing about polygons?
No!
So, anyways, this is an example of a quadrilateral. We can tell that it's a quadrilateral based on the number of its sides.
So now that 𝓳𝓚 has explained it, let us recall. We can identify what type of polygon it is based on the number of its sides. But take note, the minimum side of a polygon is only 3.
But most people can't tell if it's a polygon or not. Does anybody know how?
I think I know this one.
Yes, Porky?
I think it's not a polygon if it has no sides. It's not a closed figure, and if it has two lines in one vertex.
Yes, Porky. Great job. There are factors of why some shapes aren't classified as polygons, because a polygon must be made up of 3 or more straight line segments. There are exactly 2 sides that meet at the same vertex.
I'll take it from here. So, an interior angle is an angle formed by 2 adjacent angles inside the angle. Meaning to say, interior angles are like the corner of the whole angle of the vertex inside the angle.
And if there's an interior, there's also an exterior angle. Unlike interior angle, an exterior angle is like an angle formed by 2 adjacent angles outside the polygon. Who can interpret what I said?
Me!
You're surely excited. Come on, tell us, Forky.
So it means that we're going to extend the polygon by a side, like this!
So, to include the conversation, an interior angle is the angle formed by 2 adjacent angles inside the polygon. Meanwhile, an exterior angle is formed by 2 adjacent angles outside the polygon. Oh, before I forget, a side is one of the line segments that make up the polygon. Vertex, on the other hand, is a point where 2 sides meet. That's all.
B, you forgot about the diagonal.
Oh, right! Sorry for forgetting about that. So, anyways, a diagonal is formed by creating a straight line by a non-consecutive vertex. Get it, kids?
Oh, and did you guys know that there are different types of polygons too?
Of course, Porky. I finished school with a degree in mathematics.
Yeah, I'm not talking to you, 𝓳𝓚. We all know that you're good in math already. So, going back, there are exactly, 3 types of polygons. Number 1, equiangular polygon. There are polygons that consist of equal angles, just like 𝓳𝓚's personality. An example is a triangle.
Yes, because a triangle has equal angles. For example, here is a triangle. We label them as A, B, and C. We can identify it as an equiangular polygon because whenever you see it, it will still be equal. For example, is angle ABC, angle CBA, angle BAC, and more.
Right. Moving to the next. equilateral polygons and polygons that have the same sides. An example is a parallelogram because the up and down, left and right are equal or the same measure.
And last, regular polygons. They are both equiangular and equilateral, meaning to say they are both same angles and sides. An example of this is a square. But how? By applying diagonals. We can identify its same sides and angles because the diagonal will split the square in half, making the angles and sides much more equal. Does anyone here knows how to find the diagonal in a regular polygon? I guess none. But anyways, in a regular polygon, to find the number of diagonals, you need to subtract the number of sides in 3. So the formula is the number of sides minus 3.
Oh, I get it now. Can you explain how to find the sum interior of the angles and each interior angle, please? Can you also explain on how to find each interior angle and the number of sides?
Sure, go ahead.
Now, to find the sum of interior angles, we need to subtract the number of sides into 2 and multiply it to 180 degrees. The binomial n minus 2 times 180. While finding that each interior angle is the same as finding the sum of interior angles, but we need to divide it to the number of sides. The binomial n minus 2 times 180 all divided by n. To find each exterior angle, we need to divide 360 degrees into the number of sides. The formula for that is 360 divided by n. And to find the number of sides, we only need to divide 360 degrees into the exterior angle. And remember, when you add the exterior and interior angle, the result should be 180 and the sum of exterior should always be 360 degrees. Hey guys, now that we have finally learned about the different formulas just to get the measurements of a polygon, why don't we try this example? I'll give you a few seconds to answer this equation. And done. So let's answer the example. First, let's identify how many diagonals can be created in a pentagon. Good job! 2. And then, we'll need to find the sum interior angle. So first, we're going to subtract 5 by 2 and then multiply it by 180. So, we're going to multiply them now. 3 multiplied by 180, which is equal to 540. And then, divide the product by the number of sides, which is 5. So, 540 divided by 5 is 108. The pentagon's each exterior angle is 108. Now, we all know that the sum of the exterior angles are 360. So, to find each exterior angle, we need to divide 360 by 5. So, the exterior angle is 72. Great job, guys! So, in conclusion, the pentagon side is 5. The sum interior angle is 540 degrees. It has an interior angle of 108 degrees. Meanwhile, its exterior angles are 72 degrees.